So good afternoon, everyone. Thank you for joining this webinar on Azure Synapse Analytics. On behalf of Contact, I would like to thank you for coming here. So let's start with a quick introduction about me. My name is Dhruv Joshi. I'm a senior engineering manager at Contata. I have more than 15 years of experience in data industry, and I'm currently heading the data team at Contata Solutions India office. I specialize in architecting solutions for Google and Microsoft cloud platforms, and I have experience in multiple industry domains. Let's quickly move to the webinar part. This is how we'll move today. First, I'll give you an Azure Synapse Analytics overview. What kind of service is this? Some basic details about Synapse, some features of Synapse, a quick demo on Synapse, and we'll try to compare the other Azure offerings for analytics with Synapse. And we'll also try to decide when should we use what service on Azure for analytics. This will bring in some clarity. So let's start with Azure Synapse Analytics overview. So when this service was launched in 2019, the idea was that this will be a limitless analytics service that brings together enterprise data warehousing as well as big data analytics. So what exactly is Synapse? Synapse provides a unified platform for data ingestion, data preparation, data management, and actually doing analytics right inside the same system, as well as big data management and machine learning on top of this. So we are traditionally familiar with data warehouse technologies where we prepare ETL data, prepare and ingest it and store in data warehousing format, which can be moved to analytics tool like Power BI, where we can create models for UI and show the graph and chart to different users. Very often there are different types of users who are using different types of tools. There'll be users who will be using Power BI. There will be users who will be working on SQL, creating data warehouse scripts and manage the whole solution behind the scenes. Then there'll be ETL developers who will be working on pipelines, the DevOps people who will be working in maintaining the connection between these places. There will be data scientists who would like to play with data directly, unlike create notebooks, Spark clusters to run these notebooks. So there are a lot of different users who are working with different data at different phases, and all of this is kind of all over the place. If you're on a big cloud like Azure, that means there's a lot of DevOps required to manage each of these services, the platform taking into account cost, and multiple different resource groups, resources need to be provisioned. So Synapse solves this problem by providing a single place for doing all of this, a single UI interface, Synapse Studio, for working on this. So in a sense, it's an amalgam of enterprise data warehousing using SQL. So on the same tool, you can use SQL for data warehousing. You can use Spark for big data processing. You can write your pipelines and do ETL, or you can analyze log data using Azure Data Explorer or query language. As well as you can create data sets for Power BI and visualize reports right inside the same tool. Also, it has built-in monitoring where logs can be seen inside Azure Monitor. You can see details as in like what queries have you run, what pipelines have been running, how many KQLs have been running, what was the cost, those kind of things. As well as you can add purview for data classification and cataloging. All of this is imbued with Azure guarantee of security, scalability, and availability. Where does Synapse draw its power from? So Synapse, like every other parallel processing system, separates the storage and compute. So when we're not running anything, we're not paying for compute. We're just paying for the storage, which is cheapest because it's part of Azure Data Lake system. So ADLS Gen 2 system provides cheapest blob storage outputs and quick access to them. So the cost is kept at minimum. We can also do Apache Delta Lake on Data Lake. So Delta Lake format is also supported in newer version of Synapse. We can create our own Spark pools, SQL pools. SQL has two different flavors. There's a dedicated SQL pool when you want to create a dedicated data warehouse, which is always available to you, which is the traditional approach of creating facts and dimensions. Or if you just want to run ad hoc queries, or you have a small time in which you want to run SQL queries against a particular for data preparation, then you should use serverless SQL pools. The Spark pools are also the auto deallocated. So if you run a Spark pool and then leave it running, forget to shut it down, there are settings that you can control that it will shut down automatically after 5 to 10, 15 minutes of inactivity. And of course, there are integration runtimes which act as serverless compute engines when you are running things across data flows and pipelines. We allow multiple different computes and a single storage on which we are keeping everything. So this way, it kind of looks like this. If you see things here, there is the pipelines which prepare and bring data from different sources into Azure Data Lake storage. And this is all part of Synapse. And then you can run any of these compute services. You can use Data Explorer pools, a Spark pool, a serverless or dedicated SQL pool to crunch this data and push it out into a different place like Power BI, Cosmos DB, or Cognitive Search. And at the same time, you can discover and govern this data using Azure Purview. Okay, you get all the other stuff from Microsoft Azure Cloud for controlling access, RBAC access, POSIX access, as well as Azure Active Directory based access. You get the cost management. You can use Key Vault for secure access. You can use Azure Monitor, Microsoft Defender, and as well as integrate with Azure DevOps or GitHub repositories independently. So go back here. I'll also show you one of the other features that if you are creating metadata on the or basically defining your tables on top of your files stored in Apache Delta Lake format or Parquet format or even a ADLS Gen 2 format, and you define these files belong to this particular table and they create this table view, Delta table, you can share that metadata between Spark and SQL pools. So you just need to define it once, it gets stored in a central place and it gets shared between Spark and SQL pools. And finally, it also provides you templates for common jobs for databases, for Spark notebooks, in basically for anything that you may require inside them. We'll get to some features here, and we'll start with features which are available as part of SQL. Even though this is not complete T-SQL, which is available in a Azure SQL database or SQL Server database, but it's more or less similar. It covers 70 to 80% of the required functionality that you can help you in creating the data warehouse technology, seamless facts and dimension tables inside Azure Synapse. So as I said, it provides both serverless and dedicated SQL pools. And because it is able to store data in storage and use serverless compute on top of which can be auto scaled, it provides a distributed query system which allows for massive parallel processing. So unlike the SQL Server where you may be running on a dedicated thread, and if a long running process, it's not able to parallelize itself, here we are actually able to do massive parallel operations and get things done faster. There are different data virtualization scenarios which allow you to connect to different sources and basically encapsulate behind a connection without even worrying about the data or where you actually accessing data from, whether it's from Lake, whether it's from SQL Server, or whether it's from coming from Synapse Link via chain data capture. It can handle both streaming and batch data. This is one of the biggest advantage of using Synapse over any other systems. Like any other modern data warehouse system, it is able to catch both batch and streaming data. So you can continuously stream data and get near real-time results inside your SQL. You can also use SQL Server-based machine learning models using T-SQL predict syntax. And you can establish chain data capture with OLTP databases, any sort of OLTP database using Synapse Link. One thing that Azure users actually miss many times is that they are unable to do a cross database query. This is available in the serverless option on Synapse. So that's a big win. I'll quickly compare and show how does a dedicated SQL pool look vis-a-vis a serverless SQL pool. Both of them have a control node, as you can see over here. This is where all the data management services reside. In a dedicated SQL pool, you always have some compute nodes available depending on what kind of provisioning you've done in dedicated SQL pool. And the distributed query system allows massive parallel processing on each of these nodes. And they are all bringing the data from the Azure storage behind the scenes. same thing happens over here, except that this is all serverless. Compute nodes are assigned at the runtime depending on the query cost and the query plan, and the distributed query process engine decides how much it needs uh, based on the query plan it has generated. So it manages things on the runtime. So if you do not need a lot of SQL operations all the time 24/7, and you just need some data crunching for a small amount of time, and you're familiar with SQL syntax, serverless SQL pool should be an answer. But if you want to maintain a data warehouse which can be queried at any point of time, then dedicated SQL pool should be your answer. Apart from SQL, it also supports first-class Apache Spark integration. Apache Spark is the most popular open source big data engine, and it can be used for data preparation, data massaging, data engineering, ETL, as well as machine learning. You can basically include any sort of libraries and do a lot of different things with Apache Spark. Apache Spark inside Synapse has simplified the cluster management, so you don't have to worry about managing these clusters. These are managed behind the scenes by the Synapse service. It provides auto scaling and a quick start of cluster. It has built-in support for .NET for Spark. You can write your machine learning algorithm using Spark ML or even integrate with Azure ML pipelines. It has preloaded Anaconda library. So basically most of the stuff that you require for quickly starting a Python program, you can quickly do that. It also has Apache Levy, a REST API-based Spark job server to remotely submit and monitor the jobs. So everything is being monitored 24/7. Anything that you run will be logged and available in Azure Monitor. And I said you can mix Spark and SQL. So because they share the same metadata, you can create tables over files in data lake using SQL syntax, and these can be seamlessly consumed by Spark or Hive jobs. The SQL and Spark can explore and analyze Parquet, CSV, tab-separated files, or JSON files stored on data load. Both of them can access both sides of file. And the data loading between SQL and Spark databases is very, very fast and scalable. And they continuously share metadata between SQL and Spark. So you can have a SQL syntax running and creating a table, and Spark is able to quickly detect a new table has been created. So they go hand in hand, and they are continuously in sync. For ETL engineers, it has features for pipelining. Now, this is very similar to Azure Data Factory, and it has the same data integration engine, which allows you to create ETL pipelines with a lot of different features, copy activity, loops, programming concepts, and orchestration using triggers. You can create window-based triggers, you can take cron triggers, or you can create event-based triggers. You can orchestrate basically notebooks run inside the ADF pipelines. Just like in ADF pipeline, you can run inside Synapse pipelines, you can run Spark jobs, you can run stored procedures on SQL or just subscripts. And basically all of this is code free. We have currently about 90 plus connectors, and they are growing rapidly. Every month we is adding a couple of more connectors. You can also use data flows, which allow parallel processing using Sparks behind the scene inside Data Factory pipelines, which is a quick way to load or extract, transform data, do all of that without writing code on the UI, just by configuration. It's as fast as Synapse and Spark. We also have Data Explorer, which is currently in preview. This is used to analyze, terabytes of log and telemetry data, which keeps accumulating. You can bring all of that using Synapse ETL into a single place on Lake, and then build near real-time log analytics and IoT analytics solution. It is specially optimized for efficient log analytics. It provides full text search. It automatically indexes the free text as well as semi-structured data. So it kind of on the same scale Elasticsearch, though this is in preview, but it's a very, very efficient and very powerful technology inside Synapse. I'll shift to a live demo. So I'll stop sharing and reshare Azure portal. Okay, so this is how my Synapse workspace looks like. I've created a Synapse workspace here, and First thing I do, I quickly take you to overview tab. You can see the resource code. I created a workspace inside it, and it provides you all the documentation over here. You have a link to a documentation. You have a link to Synapse Studio. If you click on this link, this will open a Synapse Studio. We'll show how the Synapse Studio look like. It is a quick overview about the pools that you have for compute available. You have SQL pools, Apache pools, or Data Explorer pools. If you don't have any, by default, you get a built-in SQL serverless SQL pool. It comes in default, and then you can create any Apache Spark pool or a dedicated SQL pool at any point of time. But this SQL pool is always a built-in SQL pool for running things quickly on SQL. So you can go to SQL pools and create a new pool, and it's as easy as just giving a unique name. Decide the capacity that you need. Maybe let's create a low capacity one. It gives you a continuous estimate of how much cost is going to cost you per hour. Okay. And because I'm creating a dedicated SQL pool, I can lower down the cost even smaller. And click and go on additional settings where I can say decide where do you want to back up the data, if you want backup, if you want restores, what kind of collation it requires. So I'm just going to cancel this one out right now. So I'm not going to create it. I'm going to keep working with the serverless SQL pool for this particular demo. And this is my Apache Spark pool. For this demo, I've already created a Spark pool. It's a small vcode, 32 gigabytes, 3 to 10 nodes pool. Auto scales between 3 to 10 nodes. And the process is as similar as dedicated SQL pool. You can just create a demo Spark pool. You can isolate the compute. You can decide kind of node size. Is it memory optimized or hardware optimized? You can choose a small one. You can decide whether you want to auto scale or not. If you want, because auto scale is enabled, I can auto scale between 3 to any amount of nodes here. I can decide the minimum maximum number of nodes, or I can simply disable it, in which case I just need to supply how many nodes should be there without auto scaling. And then it gives you a quick idea about the costing. I'm not going to create this one. I'm going to work with my smaller Spark pool. So I'm just going to cancel out of this. And again, you can also create a Data Explorer pool over here. Pretty much the same thing. You can give it a name. You can decide on a workload and a size. And I'm going to create this one again. Go back here. And you can add, you have a couple of different options like any other Azure resource. You can provide your own encryption key for encrypting data at rest transit. You can supply that over here. You can control the networking over here. You can decide which endpoint should be able to connect to it. And you have all the basic Azure alerts features over here. You can monitor and set up alerts for different things, or decide on what metric should be bubbled out for alerts. Look at the logs and look at the SQL advisor, Azure advisor recommendation around security and other things. You can add Power Platform automation using task and even export out a template. I'm not going to do much more, and I'm going to quickly come back here and click on Azure Synapse Studio, which will launch my Synapse Studio, which looks something like this. This is how your Synapse Studio should look like when you launch it. You have quick options to visualize and create Power BI. You have quick option to click to your learning, because if you want to get details about how does something work, you can quickly go explore, analyze, and learn. You can also get that from here, Knowledge Center. And you can start quickly working on ingesting of a single data schedule load. This is quick idea about what recent resources you consume, as well as you can quickly learn and get some of the community showcases over here. So I'm not going to do that. I can quickly click on new and start writing any of these things, all from the same studio. SQL, KQL, Notebook, Dataflow, Spark Job, Power BI, or even a pipeline. or import it from Edison server using the native format. If you have multiple Synapse workspaces, you can toggle between them by going over here. I'm quickly get down to the data tab over here. So data tab looks like this. It shows you by default the SQL databases that you may have. I have created a patient database. These are the tables inside it. Using a medallion architecture, so I have a bronze and silver layer. And these are the schemas that I've designed. There's a bronze schema, as you can see over here, and there's a silver schema down below. Now I can go look at this table into the columns and click on select top 100 rows, which will show me quickly the data that is there. Click on the run, and this looks as seamless as working on SQL Server Management Studio, which most of the T-SQL guys are already familiar with. There's no data here. As you can see, it's connected. Oh, there is data here. Here's the data which is available. You can see the data as a table or even visualize as a chart if you want to. And you can decide what kind of chart you want to create. This is just like Data Studio. You can save or export out as an image or PNG. And when it's in table format, you can export as a CSV, JSON, XML, all the regular stuff. You can name the script. You can provide some tags. You can design some details like, do you want to see first 5,000 rows or do you want to see more? And by default, it's going to connect to a built-in serverless SQL pool, or you can click on an existing dedicated pool and switch the connection here. You can change the database connections over here. You can see the query plan. Because I'm connected to Git, if I want to save this new query, I quickly click on commit, which will commit my Git repository. It's equivalent to save on your SQL Server Management Studio. So this is my SQL database. Then how do I get access to this files on top of which I created these tables? So created a connection, link connection for Azure Data Lake storage. I can create a new storage account, and these are storage accounts I have attached to my workspace. And this is quite easy to create a new one. It opens up, you give it a path, you create a name, you create a tenant, and there you go. So we need to cancel all of this now. When you click over here, you can create a SQL database, you can create a lake database or a lake house. You can connect to an external data entity, you can create an integration data state, or you can choose from one of the samples if you're just exploring by clicking on browse gallery. This will take you to templates where you can look at these database templates for doing your proof of concept work. If you click on airlines database, you click on OK, it will show you the whole schema in the preview part over here, as well as a list of all the tables and schema which is available in this template version database. You can pick and choose which we want, which of them you don't want, like that. I choose these two, maybe a couple more, and just create database. Go back here. Here's my airlines database being created. So this is the data tab, which is where typically database developers will be working using T-SQL. Then there's a develop tab, which is where database developers write their SQL scripts to be executed. So a sample SQL script looks like this. This is what we had created. Or you can create folders over here, subfolders, and write a script like this. Like this is my initial setup script. I'm running this. If I run this, all of these things will be created. So plain old SQL, or you can write your notebooks. Like I have an EDA notebook on top of my data stored in my data lake. This is typically something that a data scientist would be doing for data exploration. can run it again. And this one's using Spark Pool. As you can see over here, you can see how many pools I have available by looking at which Spark Pool it attached to, what are the details about that Spark Pool, and what is the session timeout window. As I said, we can also, in the develop mode, connect to Power BI. So I build a Power BI workspace here with a data set and a Power BI report, a couple of Power BI reports on top of this Power BI data set. There you go. On the same tab, you see SQL script, you see the imported database, you see a SQL script, another SQL script, you see a notebook, and you see a Power BI. All in its entire glory. You can see your reports, you can see your code, you can see your notebooks, all of them over here inside the develop tab. If you want to create pipelines, you will go to the integrate tab, which is where all these pipelines are. I created a couple of pipelines for this demo. And this is very similar to the UI that you have in Azure Data Factory. It works exactly like that. It just, except that probably doesn't have a couple of features like global parameters, which probably will come in soon. And you have all the things that you can drag and drop and configure. You can copy data, data flow activity, data explorer activity, call Azure functions from here, connect to Databricks, right? Connect to HT inside. You can have all the looping concepts here for each filter, if, switch, until, or even machine learning notebooks. So you can create your data factories here and monitor everything that you've been doing on the monitor tab. You can look at all the pipelines that you've run or debug. You can look at your SQL pools, which SQL pools have been used, how much they've been used. You can also look at your SQL request that you've run. We ran a top 100 record row. You can see that over here. You can look at your Spark applications that you've been running. I ran an EDA, it's still running, so it shows me the correct status. You can look at the integration runtimes that you have created for running the pipelines. The default auto-resolve integration time shows up here. And then you have Manage tab for setting up connections like link services, connection to Purview, creating triggers and integration runtimes, creating your Git configuration so that you can commit everything to your repository. At any point of time you want to create a new feature, create a feature branch, and you can start working there. And then when you are done, submit a pull request on GitHub. Once it gets merged, you can publish, come back and publish everything from here. So if I hit on publish, it says it's going to publish everything to the main Git repository, and then the DevOps pipeline can be triggered from there. Okay, so this was a demo. I'll go back to the presentation. Now, why do we want Synapse? Why not something else? So we were going to compare a couple of Azure offerings. Our goal behind Synapse was to democratize data and analytics and decentralize a domain-driven ownership for data products, which is kind of definition of a data mesh architecture, by providing a self-service platform. There are three options for integrating Azure Stack, which offer analytics. One is creating a data warehouse using Azure SQL, getting the ETL data done using Azure Data Factory, analytics on top of using Power BI, more orchestration using logic apps, and Azure functions to take care of REST API connections or microtask. We have Azure Databricks, which is first-class implementation of Databricks technology, Apache Databricks into Azure platform using Azure Data Lake as storage and Parquet file formats. Then you have upcoming Fabric, which is in preview, which Fabric is something which allows, which Microsoft is offering as the silver bullet for all sort of analytics options. So we'll look at how Fabric and Synapse compare. We'll look at how Synapse and Databricks compare. We'll also look at how Synapse and data warehousing using ADF, Azure SQL, and all those applications compare. So when should be using Azure Data Factory, Azure SQL, and when should be using Synapse. So in the first case, you have assortment of Azure services that you've tooled together, glued together to work and accomplish your analytics goal. You have to provision each of these services, which is an overhead, especially when you have to write Terraforms or write scripts to do IAC on top of these. Uh, this is exactly the use case which kind of led to migration towards Synapse for very big corporations. You have to manage so many things, so why not just manage one thing inside Synapse? It is suitable for a precisely engineered analytics solution. So if you have a very custom engineering solution where you try to manage everything on your own and you want optimal control and you want integrations with third-party services outside Azure, you don't have a data connector available, that's available via the Azure function or data factory, and you want very good control on top of it, then probably you'll be using Azure Data Factory, Azure SQL, all these services together. It is also a good uh, answer for lift and shift to cloud. If you have an existing, let's say, SSIS solution and you want to move to cloud, you can do a quick lift and shift using Azure Data Factory and Azure SQL as a first step before moving on to something else like Synapse. You have fine-grained control versus ease of use. So these are the parameters. If you want ease of use, you probably would want to go to Synapse Analytics. If you want a fine-grained control, you probably want to go to Azure Data Factory and Azure SQL. Fabric. Fabric is touted as a natural successor of Synapse. Microsoft plans to discontinue Synapse when Fabric is generally available and encourage everybody to move to Fabric instead. However, at this point of time, Microsoft has not defined a forward migration path for Synapse user to Fabric, so that's something to watch out for. If you're committed to Synapse and tomorrow you want to move to Fabric, you'll have to probably to migrate manually. There is no migration assistant at this point of now, but that's not a big thing because Microsoft has done these things in the past. It's come out with a tool and say come up with a migration utility later on for everybody to migrate. So they may give you a migration assistant later on. Now, this is in preview for next year or so it is not recommended for any production work, though organizations started working on using it because of its utility. Fabric currently does not have support for open row set syntax, which is kind of the biggest thing when you're working with Synapse. You have a file on the link and you can configure what columns do you read from that particular file using an open row syntax inside SQL queries. Fabric doesn't have very good support for tsql for managing this workload. It tries to hide that all of those things behind UI rather than allowing you to write SQL. So if you're somebody who's very SQL savvy, database background, Synapse might be the place for you. But Fabric, you'll have to quickly run some wizards and stuff to do these things. The data warehouse data in Fabric is pursuing technology called OneLake, which is a little superior technology in terms that it's using Delta file format compared to Parquet file format. Fabric also has a great feature for direct UI-based data capture called shortcuts. This is kind of very similar to your Synapse Connect service, link service. Here you have shortcuts, which is very much like OneDrive kind of features to grab data by just drag and dropping, and there you have the data. So Fabric is good and a natural successor of Synapse, but it's not ready right now. Then we have Azure Databricks. Databricks supports a wide variety of query languages like Python, Scala, or it's not limited to T-SQL in Spark Python. It has many more options available. It is actually the tool of choice for serious machine learning experts, people who are invested in data science. It provides lakehouse architecture style versus the three-layer architecture style that we've seen on Synapse. Synapse is a simple three-layer architecture. You have the pipelines for ETL, you have storage on Azure Data Lake, and then you have variety of options, Spark pools, syndicate SQL pools, KQL pools for the compute. So that's a very simple three-layer architecture. But lakehouse architecture, we've done a webinar on that. Maybe you should refer to that. And as for the recording, but lakehouse architecture is the latest architecture using Delta Lake technology, and Databricks working on that. Databricks has a more robust ELT, not ETL, mind you, a more robust ELT. You extract, you load, and then you transform. Feature set, it has a very more robust data science and machine learning feature set. You find shortcuts or methods to do some of these things very, very quickly on Databricks compared to Synapse. The cost on Databricks, however, traditionally on the higher side compared to Synapse, even though Synapse pricing is very complex, but Databricks costing kind of turns out to be typically on the higher side. Databricks provides a better real-time support with Spark structured streaming as well as autoloader technology that's come up with. It also provides good support for machine learning workflows with GPU-enabled clusters. So that kind of is where Synapse lacks. It doesn't have GPU-enabled clusters. Databricks provides automated versioning in collaborative development notebook. So on Synapse, if you're working on notebook, you cannot have two developers working on their screen on the same notebook. That doesn't work that way. And in this age of document sharing, that's kind of very, very important that you have collaborative development methods. Databricks does provide that, Synapse doesn't. So Databricks overall is feature dense compared to Synapse. It's more suitable for data scientists in companies who are serious about data science work. And if you're a corporation which relies on large scale data scientists doing their work, maybe you should be using Databricks or Synapse. So exactly when can we use which of these tools? So we have a graph from left to right. We have seriousness in terms of from engineering to data science. So if you have more engineering work, ELT, ETL, analytics work, right, we probably should be using the custom stack of data factory, SQL, data warehousing, those kind of things. If you have more of data science, machine learning, notebooks, Spark, parallel processing, batch processing, those kind of work to be done, you should probably be using Databricks. If you want a midway point where you have all of these nice things built into a certain extent in a single place, this is where is a large use case for about 60-70% of the audience, which is where you have Synapse. You get lower costing than Databricks, almost 80% of those feature sets. You don't have to manage as much as you have to do in a custom solution using Data Factory and ATF. And all of this comes nicely integrated in a single studio. And comparing Fabric, Synapse is going to move into Fabric as a next step of evolution on Microsoft stack. So they're kind of on the same path, yeah, but they're going to be more rich and compatible with Databricks in future, and probably be the only analytic solution around the Microsoft stack. So that's it. Thank you. I think if you have any queries, you can ask me now. We will take some question and answers now. If you don't have any queries, you can check our website and get updates on upcoming webinars. There's a new webinar coming about Fabric next week or so. Or you can contact our sales team at sales@contara.com. So thank you for listening patiently.